Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be learning about Gaussian mixture. So, Gaussian mixture is a statistical model that helps us understand and describe complex patterns or distributions in data. To understand Gaussian mixture, let's imagine we have a bowl of different colored candies. Now if we were to choose our eyes, if we were to close our eyes and randomly pick a candy, there's a chance we could get any color. Some colors might be more common, while others might be rare. Gaussian mixture tries to represent this distribution of colors using a combination of multiple bell-shaped curves called Gaussian distribution. Each Gaussian distribution represents a group of color that tends to occur together. For example, one Gaussian distribution might represent a group of candies that are mostly red, while other might represent a group that is mostly blue. These distributions are bell curved describes the probability of picking a candy from each group. To create a Gaussian mixture model, we need to determine the number of Gaussian distributions, their mean, average color, and their spread variance. We do this by analyzing the data and finding the best combination of Gaussian distribution that accurately describes the observed pattern. Okay. Now, once the model is built, we can use it to generate new candies. We do this by randomly selecting a Gaussian distribution based on its probability and then randomly picking a color from the distribution. Gaussian mixture is useful in many applications. For example, in image processing, it can be used to represent different textures or objects in an image. Each distribution represents a different texture or object, and the model can generate new images by combining them. Gaussian mixture is like having a bowl of candies with different colors. Each Gaussian distribution represents a group of colors, and model help us to understand the probability of picking candies from each group. It can also generate new candies by randomly selecting distributions and colors. Okay, so now let's get to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. So and their values will be stored in x, and for the features, and for prediction class the values will be stored in y. X will have all the data that our user will give us as the input, and y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to train here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7:3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so now we have reached the most important part of this presentation. So here we will import Gaussian mixture from sklearn.mixture library and assign it to a classifier variable. We'll fit the classifier or the model with the training data, that is xtrain and ytrain, and we will predict the data from or using the model on the xtest, and will store it in the ypred. Now we will import metrics from sklearn, and using the accuracy score we will calculate the accuracy using ytest and ypred variables. Now every time ytest and ypred being same, the accuracy will increase, and the times when they are different, the accuracy will decrease. Now since here the accuracy we have got here is 0. Now this is because of the nature of the Gaussian mixture. So let me I'll explain you this when I'll be explaining the conclusion, so you'll get a better understanding of this. So let's move to the VS Studios to get a practical implementation of what we have seen here. Okay, so now we have come to our Visual Studios. So let me just show you a quick working of Gaussian mixture. So I have written this code earlier, so I'll just run all and explain you all the code line by line. Okay, I think the code hasn't run yet. Just run it one by one. Okay. So firstly, here we will import the pandas library, and by using the read CSV function, we will read the dataset, that is iris dataset, and using the info function, we will take all the information of the dataset. So here we can see that there is total 150 entries from 0 to 149. Each column has 150 entries with each nominal values, and the data types are written here. So here you can see that the data types are like four float 64 data type and one object data type, and the memory usage is around 6 KB. Now here a method I have just shown. There's another method of doing the same which I have explained in my earlier videos, so you can just check it out. So here I have defined two classes, features and prediction class. So features are those class that a user will be asked as input, and the prediction class will be the one that a person has to get from the model. So I'll just run it. Now I'll get the values of features in X and get the values of prediction class in Y using this dot values function. Okay, so I have stored I have stored the data values in X and Y. Now, from using train test split, I'll just split the data as explained in the presentation, and we'll check their shapes. So, okay, so here we can see that the training data is more and testing data is less, as it is suggested to do. Now, from sklearn.mixtures, we will import Gaussian mixture and store this Gaussian mixture classifier into CLF variable. Now we'll fit this model with X-train and Y-train data, and when this model is trained, we will predict X-test values on the basis of this model and get the output, and will be stored in Y-print variable. Okay, so I will run it. So all this process is done. Now we'll try to get the accuracy. So here you can see the accuracy is 0. We have achieved an accuracy of 0. So from this we can say that this model is the least you can say is the least good, is the least means it could be, it is not good for this data set. Simply, to put it simply, it is not good for this data set because it is giving an accuracy of 0. Whatever it's working is, it is not supposed for iris data set, so it is giving an accuracy of 0. Similarly, we can work this algorithm on different data sets like pima data set or any hard data set. So you just have to replace this data set from its name and assign the column names in this feature and prediction class. Take its value to y, then assign this value and split the data in the x-train, x-test, y-train, and y-test, and just fit the training data, and predict on the basis of x-test. So this was it. Now moving to the conclusion part. So, Gaussian mixture model have diverse applications in areas such as image segmentation, data clustering, and anomaly detection. Their ability to model complex data distribution makes them suitable for problems where the underlying data distribution is not easily separable or follow a mixture of Gaussian distribution. Gaussian mixture model offer the advantage of flexibility, allowing for different covariance structure and capturing data variability. They can handle high-dimensional data and are robust to outliers. However, training Gaussian mixture models can be challenging due to the need of estimating parameter and potential for convergence issue. Additionally, determining the optimal number of components require domain knowledge or using technique like Bayesian information criterion (BIC) or cross-validation. Interpreting the results of Gaussian mixture model may also be less intuitive compared to other clustering algorithms. So I think from this short conclusion, you may have got a pretty much idea of why we have got the accuracy for this on the iris dataset as 0. If you have any doubt, please comment us and we will surely answer your query. Okay, so this was pretty much it, and happy learning.